Good day, guys. My name is Mr. Daimani. I am a maths teacher today. We'll be focusing on senior phase, specifically grade 8. We'll be doing exponents, right? We want to do exponents. Our chapter is exponents. Right? The resources that I've managed to have are these worksheets for you guys. I normally use a prep book for these lessons and the textbooks that are in front of you. Yes. Now, let's focus or let's look at these exponents. We have laws of these exponents, right? Okay, before I go to laws of exponents, let's first break down what are exponents, right? So if you have a to the power x, now remember, I know you might dealt with this previously, but listen carefully. Now, a, we call it a base. We call a base, and we call x a power, or we call x an exponent. We call x a power or an exponent, same thing, right? We call a base, right? Let's go straight to our, where's my eraser? Let's go straight to our laws of exponents quickly. I'm timed here, so I have to be quite fast. Laws of exponents. We have quite a few laws of exponents, but our first law will be multiplication. Our first law will be multiplication of exponents, right? Multiplication of exponents. Multiplication of exponents, right? Now, this is our first law. I don't have space here. I will write, then you have to write down so I can write back again, right? Because I don't have much space here. Now, what will happen is this now. If you have a base of a to the power x multiplied by a base of a to the power y, the answer, if you have multiplication between these two bases or these two variables, if you're multiplying the same bases, this law states that if you are multiplying the same bases, you actually add the exponents. If you're multiplying the same bases, you do what with the exponents or to the powers? You add them. If you're multiplying the same bases, you add exponents. So on your answer, you only write one base, right, guys? We have two bases that are the same. On your answer, you only write one base and you add the exponents. Let's make an example quickly. Example. Our first example, when I say we have b to the power 3 multiplied by b to the power 2. You see, you have b and you have b, you're multiplying the same bases, right? You have b, you have b. So if you're multiplying the same bases, you actually add the exponent. But here you only write one base. So it will be b to the power 3 plus 2, which makes b to the power 5. That will be your answer. That is our first example of this. I've created a couple of examples. Another example of this first law. Let me write this. You're done writing now? Okay. Now, another example of this first law. Let's write quickly. Another example of this first law. When I say, okay, we have 2 to the power 3 multiplied by 2 to the power 4. Same bases again. If you have same bases, you actually add the exponent, but you only write one base here. So you're going to have 2 to the power 3 plus 4. That gives you 3 plus 4, it's what? 7. So the answer is 2 to the power 7, right? That is very good. The last example, I need to do this because now you think maybe on this law, it only applies when you have two variables or two bases that are the same, even if more than 2. Now let's say you have a to the power 3 multiplied by a to the power 7 multiplied by a to the power 4. Now they say that I write the answer there. You see, still the same bases, right? Same bases, you add the exponent. You only write one base regardless of how many bases you have on your left, right, guys? Now you have 3 plus 7 plus 4. What is your answer there? 3 plus 7, it's 10, plus 4, that is 14. So you have a to the power 14. That's how this law goes. Now, any questions? Oh, you're right, okay? Now let's go to our second law. Let's go to our second law, and our second law is division of exponents. Okay? I don't have space, so I have to erase every time. Our second law, that's what laws of exponents are. Our second law is division of exponents. Exponents. That is our second law. So how does this law goes? Now if you have, again, a to the power x divided by a to the power y. You see we have division now, we do not have multiplication anymore, right? Now, what happens is this, we still have the same basis, right? We still have the same basis, and I said if you have the same basis, you always write one base on this side, right? This is division, it's not multiplication. So what happens is this power, when it goes to the, we call this a denominator, we call that part a numerator. A division has two parts. We have an upper part and a below part. Now this we call a numerator, and we call this a denominator. A denominator, you see this y here, it's a power of that a on the denominator side. So when this y goes up to the numerator, it changes its sign, right? You see now we have positive here. When it goes up, it will become negative. Hence it says here, if you have a division, you have the same basis. Now your answer will be x minus y, because this y came from down going up, right? So x minus y. That is the law of division of exponents. That's how it goes, right? Let's have a couple of questions or a couple of examples quickly. Now, let's say you have, roughly, you have 2 to the power 4 divided by 2 to the power 2, right? Now, same basis, so you have the same basis, and on the numerator you have 4, this 2 will go up, it will change the sign, it will be like that, right? So what do you have there? 4 minus 2 is 2, so your answer is 2 to the power 2. That is your answer. Let's try and do another example quickly. Let's try and do another example quickly, guys. Let's say you have a to the power 5 divided by a to the power 3. Same basis, but we have division, not multiplication, right? So you write one base, and you write the one that is in numerator, but you know this one that is in denominator will go up more, so it will change its sign. Because it's positive, it will become negative. So if you have division, basically if you have a division of exponents with the same basis, the exponents are subtracted. So if you have division, you subtract the exponents. You understand? Now, a 5 minus 3 gives you 2. So that is your answer. That's how you do it, guys. That is how you do it. I have an activity planned for you there, but now I need to explain these examples and these laws firstly. Then you'll ask questions if you have questions, but I can see you all understand what I'm talking about, which is great. Now, I'll do all of these laws, this couple of laws. I won't do all of them at once because it will confuse you. Ne? Now I'll do a couple of them, maybe 3 at first. Then we're going to do an activity to see, I want to see if you actually understand what we're talking about. And after that examples, or after that activity, we're going to do corrections where you maybe made mistakes. Then after that, we're going to continue with our laws. Now, our third law is raising a power to another power. Raising a power to another power, guys. Third, raising a power to another power. What does that mean? You can even see most on the title, raising a power to another power, which means we have 2 powers. So let's say if you have a to the power x, all in bracket y. You have a to the power x, and you all have a power y after the bracket or over the brackets. Now, you know, this is the base, you don't have any bases, you only have 2 what? You have 2 powers. Now, this law says, if you have this, the 2 powers multiply each other. They are powers, so they are multiplying each other. So you have a, x should multiply with y because they are both powers. Powers multiply each other, right? So your answer is a to the power x multiplied by yy, because parentheses brackets, it's multiplication. So these powers actually multiply each other. Does it make sense? Now, for example, let's say we have an example, x to the power 2 all over 3. What happened there? You have x, but you have power 2 and over the brackets you have 3. So these two powers will multiply each other. So you're going to have 2 multiplied by 3.